Hello, everyone, and welcome to another episode of WWT Experts. I'm your host, Matthew Coble, and today we'll be talking with WWT expert David Robinson about data pipelines. David is a leader in Worldwide Technology's digital manufacturing and distribution team, and he's got many years of experience with industrial automation, IT security, Internet of Things, and the related technologies that exist in that space. He's worked with a variety of clients over the years on these topics, and he always enjoys learning about new technologies, new processes, new ideas that he can bring to his work. So we're delighted to have him with us today. So, David, welcome. Glad to have you with us today. Great to have you here.
Yeah, thanks for having me, Matt. I'm really looking forward to this session and hopefully be able to provide some good information for everybody.
Yeah, likewise. So let's jump right in. So, first question for you, what is the current state of data collection and management in the operational technology space?
Well, obviously it's very different, with every different manufacturer, so you can't say that everybody is exactly the same, position. But generally, there's a consistent theme across most manufacturers. And what that is first and foremost, a lot of the data that they've collected over the last, decades or so that, numbers of them have been capturing, it's stored in singular systems. So it's in silos, effectively. And that makes it really, really difficult to get access to. So often you hear of stories, where they want some production information or some quality information, and it exists within their estate, but it exists within a locked-in system, and it's very difficult to retrieve. So that's one of the biggest challenges that manufacturers face, and it's very common across all types of industry. The second one, the major status of data management with manufacturers is really poor data management. And what I mean by that is when it's being collected, it may well be being stored, and it may be being used for historical purposes, even to evidence for compliance reasons. But generally, it hasn't been stored in a constructive way that's meaningful to the process or the manufacturing environment that they're in. So it tends to be in a format that's understood by very specialized engineers. It may be in an engineering vernacular, and therefore, again, it can't easily be understood. And therefore, because it can't be easily understood, it can't be easily turned into information and then can't give insights, which is really what the business value is of gaining from manufacturing data when it's collected.
Well, David, I know that a lot of organizations are really starting to recognize the importance of consolidating data into data pipelines. What's driving that thinking?
Well, it just follows on from what I say is collectively, manufacturers have had pockets of data collection for operational purposes. It may be for controlling the plant lines, controlling the process, managing alerts, things like that. The data's been collected for that for many years, for those specific purposes. But what manufacturers are saying is, well, I need to have a more holistic view of my whole, my whole plant, which involves the process, the environment that the manufacturing equipment's encapsulated with. And they need to be able to tap into all of these disparate data sources and new data sources that are continually being asked for. Things like energy consumption around, ESG initiatives within organizations. So what they then seen they needed to do is to try and find a way to consolidate that data, all of that data, into a standard infrastructure so that they can begin to, feed that data into the manufacturing data pipelines, into this standard infrastructure in a controlled and managed format that then can be protected, it can be transported throughout the whole enterprise for all different stakeholders to be able to have access to. So it makes sense to have some sort of system, some sort of common architecture there to be able to not only collect your data, process it, store it, but then make it available to the widespread stakeholders that exist within any organization.
So what should we be thinking about as the components of a smart data pipeline and the architecture that supports that?
So it can be broken down into probably around about 6 different components, depending on how you think of it. But the first and foremost is the connectivity, the collection, where the ingestion point, so where do you actually connect and collect the data from? So there's some standardization there about what sort of protocols you use, what sort of devices you use, what sort of wireless network infrastructure you use to be able to collect that data from devices, from machines, sometimes from subsystems, because you may choose to just talk to the system rather than talking to one singular sensor or device. And once that data is collected, it then needs to kind of be processed, because not all data is good data. And if you have bad quality data in your system, it results in wrong decisions being made, and bad decisions made on bad data. So you want to process it. You want to formalize it into a common format to make it meaningful, so that insights can easily be derived from it, so that more and more people can understand where that data's come from, where in the process it sits, why it's important, and what its meaning is. And then the next phase of it is actually storage. Now, traditionally, the storage has been done on-site, on-premise, and a lot of historians have been prevalent throughout manufacturing environments, and there's some leading players that have dominated that sector for some time now. Now, with the emerging cloud technologies and cloud storage, there's some decisions to be made there as to, does it stay on-premise? Does it move to the cloud? Is it a hybrid of those? Do I collect some and keep it for a certain period of time, or do I move it all to the cloud, or equally do I split it between the two? So there's a storage element. And then after that, you've got some analytics, because you're collecting data from the plant. You're collecting a tremendous amount of data. It's ones and zeros, when the machine's turned off, when it's off, or when it's on, temperature values, pressure values. These things are changing all the time. Sub-second changes, 100 hertz per, 100 times per second collecting data. Now, you probably don't want all of that data moved to the central system, whether that be on-site or whether that be in the cloud. So you want to do some processing there. So you want to be able to filter out what you need and discard what you don't need. And that's best done down on site towards the edges. That phrase is coming into play more and more often. So there's some processing that needs to be done there. It may also be some processing around alerts, because if you want to take real-time action based on real-time, data that's being collected, again, that's something that can be done on site, on the premise. So you may want to make those decisions locally. Then after that, you want then going to look to where you're going to move the majority of the data, where it's going to be stored for the longer term, so that your business analysts and those types of people can get access to it. So there's a delivery mechanism. How is it going to be delivered? In what format is it going to deliver? What data model is it going to support? Because that's very, very important, so that those analysts understand how to access in their own time and as needed basis, and they can configure it and utilize that data to carry out their performance analysis and their machine learning, developments and those types of things. And then the last element is actually the visualization. So how is it going to be visualized? Is it going to be in operational dashboards? Is it going to be in simple Excel spreadsheets? Is it going to be using some of the data visualization tools such as Power BI or Tableau or things like that? And often when customers are going to want to talk to around it, they actually start with the visualization element, because that's what looks good. That's where they think they're getting all of the answers from. But it's actually the reverse of that. It's really important to start at the beginning, where you're getting the data, how you're ingesting it, and then follow through those stages all the way to the visualization, which is actually the last piece of it. And probably I'd say the easiest piece is visualizing the data after it's been collected, processed, and delivered.
Well, and thinking about those visualizations makes me think about like business outcomes. And I know there's something at Worldwide we always strive to do is create great business outcomes for our clients in the work we're doing. So I'm curious, what's the business value organizations can see when they do this kind of work well around their data pipelines?
Well, Industry 4.0 is a kind of a phrase that's out there about, revolutionizing, manufacturing and industry as a whole. And some of the, the big business values that are rightfully put up there and what it can deliver is around, operational efficiency. OEE is a common phrase, overall equipment effectiveness. Am I using my assets, 100% of the time? Are they always making my product? Am I maximizing my productivity? Am I improving my quality? Now, all of these things are true business values that, all organizations look to strive for and look to, reach world-class values against those. Now, in order to do that, you have to have data. Without data, everything is not meaningful. It's not current, that you won't be working on, 3-month-old productivity data. You'll be lagging behind if you're not seeing it in real time. So the real benefits are to be able to get fast and accurate data to the place of where it needs to be, in the format that it needs to be to deliver that value. But beyond that is, well, that's some of the things that's, has been done in the past, and they've been collected data, maybe on a local basis, and maybe not federated throughout an organization. But once you start to, embrace manufacturing data pipelines and look for it enterprise-wide and democratize the data, what that really leads to is continuous improvement. So it's not just about finding out what your OEE figure is here and now, but it's actually being able to measure that and plot that over time, in near real time, to be able to see that you're continually improving. And all of the changes that you are making, you can measure them against true, key performance indicators that you identify. This is extremely valuable because it also leads into being agile in your nature of changing things, but also agile in being able to change back when it doesn't quite go right. So, you become able to make fast decisions, you get feedback directly. So it just really leads to continuous improvement beyond just the value of that initial use case around OEE or productivity or whatever. So that's the real benefit for the long term, not just a short-term fix.
Well, as organizations are putting together architectures for good data pipelines, I imagine that they're probably first thinking about capturing existing data and kind of going forward from there. But I also know that lots of organizations have lots of historical data as well, and it might be valuable to bring that into the data pipelines too. So how do you counsel organizations to sort of that balance between bringing in the historical data versus having excellent go-forward data?
So that's really a common question, and I kind of be a little bit controversial in some ways of this thing, because normally you assume that if you've been collecting this data, that it's valuable, and therefore we need to continue to do that, for the future, because there was obviously a reason why we collected in the first place, and therefore we should continue to collect it and just augment that data, add more data sets, tidy it up, clean it up, and everything's going to be good. But the reality is, often there is no value in that data, because if it wasn't stored correctly and the quality hasn't been measured, improved, then it could be bad data. And the heavy lifting that could be involved with taking that old data, and it could be years worth. I mean, tremendous amounts of data could have been collected. And there's some heavy lifting involved in not only, reformatting it, checking for the quality of it, validating it against the new model moving forward. All of these types of things have to be considered. So there's a cost associated and an opportunity time that needs also to be considered. So the challenge I always say is, are you sure that there's value in that data? It's like if you were drilling for, oil. Are you sure that you're going to drill into that old well because you believe that there's new value and new oil in there? Because if you're not, then you may want to consider not bringing it in, certainly in the first instance. You can always leave it for later on and see, find out later that actually you did need it, or it would be useful for being able to, bring into a learning model of some description. But you can find that out later and you can bring it online. So I think the important thing is to think about the future think about how the data needs to look for the future and for your use cases that are really attached to business value. That's where the focus needs to be, because that's where you're going to get your biggest benefit. And then if down the road you decide or you find out that there will be value in bringing that whole data, then yes, go, exercise that, bring it in a controlled manner and feed it in. You might need to find that you actually only need a subset of that data. So you've, in essence, even if you did need that, you've, created a lesser workload. So you've saved some time and cost in being able to do that.
Well, David, I love what you've been explaining to us, and I feel like we've been more in this conceptual space. I'd love to hear if you know a couple real-world examples of how you see organizations out in the market doing this really effectively and driving some of those business outcomes we were talking about. Can you tell us a couple examples? Yeah,
sure. Try to. So, one example is and I can't disclose the actual customer because obviously there's confidentiality involved in that. But if we look at the particular process there, it's actually very large, big components, and what they're looking at there is they're looking for errors in the process as this particular large piece of material moves through the manufacturing process. And what they actually in essence have right now is they look at testing at the end of the completed product. Now, during that completed product, they have multiple phases of manufacturing that it goes through. Now, because they don't have the data to be able to monitor each individual phase and the quality associated with each individual phase, they are only going to find out about any defects, or they only find out about any defects at the entire end of the process. So what that means is if you've got, say, 7 stages of this particular process, if you have an error that's introduced at, say, stage 2, early on in the manufacturing cycle, it will have to go through all the other cycles to the end of the process before it's actually then quality checked and that defect is found. So what does that mean? Well, you've wasted all the time and effort that's taken you to move it from phase 2 through to, say, phase 7, and then you have to rework your particular piece of work, bring it back and create the effectiveness and go through the process again. So this particular company is looking at it and say, well, I'm going to use the data, I'm going to tap into new data sources, I'm going to use some new technology to be able to assess when the actual quality and defect was occurred on the individual phase, so I can stop that process. I can stop it at phase 2. I only have to then rework back those 3 phases with the process so I can reintroduce the raw materials, etc., back in. So you're saving time because you haven't had to go through those phases. You're saving any of the cost and the resources that are required for running those phases, and then you can get back up and running with the new creation of that new component very much quickly. So that's just kind of one example. And another example is actually a really simple story. Really, it's clear to as energy prices go up, for our homes and everything, it's around energy consumption. So being able to monitor exactly what pieces of equipment are doing, and seeing how they behave in certain operational conditions tells a lot about what's going on with that piece of equipment. So if you start to monitor things like energy consumption and you can see that energy is going up, which is out of the normal for a particular piece of equipment, then you can be able to presume or see that the condition of that particular piece of equipment is failing, and therefore corrective action would be, welcome in being able to prevent it getting worse. So in this other particular organisation, and they're doing it very simple. They were looking at simple air-conditioned units and being able to monitor whether the filters were actually getting clogged up. Because if they get clogged up, then what it makes the air coming in is different to the air that needs to be conditioned, and therefore the performance of the actual air conditioner is affected. Now, you can monitor things like the actual energy that is consumed from that and be able to predict that energy consumption is going up because the air conditioner is working harder, because the filter's blocked and not as being as efficient. And therefore you can see that relation between the two is happening. And then you can get out there early, and they do get out there early with maintenance. They're not waiting it for fail or any trips or alarms to go. They can go that, carry out that corrective maintenance procedure, and it's much quicker, and there's less affection in the actual environment. In this instance, it's computer equipment that it's looking at. So, those are kind of examples where data can really tell a story about what's going on places that you don't have eyes and ears on. You don't have cameras, you don't have people in these, far-fetched, facilities, whether they be in big organizations or remote organizations. So this is where data becomes your eyes, your ears, your nose, the senses of what's going on with your equipment and your operation, and can be used accordingly.
Well, David, what are some of the key technologies in this space, and what are some of the partners that I know that we probably like at Worldwide Technology or that others might consider out in the marketplace?
Yeah, there's a really interesting dynamic that's going on in this particular space, and a phrase that I think one of my colleagues spoke about in a previous thing was about IT-OT convergence, and about how IT technologies are merging into this operational technology in the plants of the world, and that really is happening. I mean, it's happened more than we know it. As I said, I've been in the industry a long time, and I can tell a number of stories around things that were going to be introduced, would never be introduced, and ended up being the norm, as it were. But so what that means is we've got a number of technologies that are being introduced from both sides of the house, as it were. So both sides, from the IT side and both from the OT side. So what I mean is, if you look at them both, say the extremities of them, shall we say, is like you've got your traditional players that are in the space of operational technology and manufacturing plants. So Rockwell Automation, Siemens, Mitsubishi, Emerson, these types of companies that have been operating in that space for a long time. They are bringing new technologies, and they're bringing adapted technologies into this space to address the particular needs that we've been described. But equally, our cloud players, so AWS, Google, Microsoft, are bringing their cloud technologies and beginning to utilize them against these same use cases. And in the middle of it is the kind of compute platforms and some of the software platforms. So we're seeing Dell, we're seeing HPE, those traditional players, the network infrastructure players of Cisco and Juniper and Fortinet. The things that are typical within the IT world are equally playing as part of a collection of components that make up a solution. Because what we are really seeing is it's no longer a fixed product to deal with a particular bespoke use cases or a set of defined use cases. What we're seeing is a much more component open architecture that's being adopted that brings in the best of breed from wherever that may be. And that could be from the cloud, that, even though it's going to be on premise. It could be from traditional industrial vendors that actually is going to be used in the cloud. So we're seeing a lot of change there. And it's really exciting that WWT are involved in that. It's a space that I've occupied in my career for a long time, and it's really good to see this dynamic change that's going on.
Well, David, something I know you like to say to our clients is own your own data and take care of it. So if one of you expound on that and tell us what you mean by that.
Yeah, sure. So it is something that I often say to, or get involved in conversations with my clients about, owning their own data and taking responsibility for that. And it reflects back on conversations I had earlier in my career, and I actually have had, more recently as well. It's where we go and look, or I go and, take a visit or a tour to a particular facility, and they describe what they're trying, the use case, what are they trying to achieve. And often the technology or the data is actually, already in existence for what they want to achieve. So they might want to look at temperature values, and they may want to extract those and relate those to the environment. So they say, well, is the temperature of this machine or this product that I'm making affected by the outdoor temperature? Well, you can correlate those two. You know what the outdoor temperature is because you're measuring it through a thermocouple sensor that's over there, and you're measuring the temperature from here because it's being displayed on your screen there, and you can see that, right? So simple task, right? Why don't you just get those together, plot those, put them in a graph, and then you'll have your correlation. And then they say, well, yeah, we understand that, but we can't get that data. And I said, well, why not? It's, you've got a PLC, it's your PLC, it's your machine. Everything about this is yours. Why can't you do it? Well, the OEM who gives us that machine and that process, they control access to it. They control the program. It's part of our contract with them to, maintain that and look after it. So we need to put in a request, and that request takes time, and there's a cost associated with it. So it's like, yeah, you've got your data, it's your machine, but you've got a custodian in there that's in the way, that's preventing you from getting your data, and therefore ultimately preventing for you to making that into information, turn it into insight and getting some value. So it's like, this is crazy. How did you get in this situation? Well, if you replay it back, it's understandable. These guys, they're not stupid. It's just that they didn't recognize that the data was going to be valuable. It was it's a resource that ultimately in time has become more valuable. So what I then say is that don't get yourself in this same situation. It's your data. Own the data, protect it, manage it as if it is, valuable, because it is valuable and it's going to become more valuable. So think with that mindset. So, when you're going in and bringing in OEMs, dictate that you must have free access to the data. You're not talking about changing their machine or anything like that and their control system or whatever their protective algorithms may be. All you're saying is, I want access to my data because I want to be able to analyze it for improvements and analyze it alongside other data sources that I have in my facility. So it's really, really important. It's valuable, own it, manage it, and take good care of it.
That makes great sense, David. And for our last question here, I always like to ask our experts to look to the future. What are you excited to see in the next 2 to 5 years when it comes to data pipelines?
Well, just to follow on that, I hope that all manufacturers own their own data.
Yeah.
That really is a hope of mine. And I say that kind of laughing because I know it's not that easy, because they get wrapped up in service contracts, and we see everything moving to as a service, and then as a service means the data's going somewhere and you might not be able to access it, and you may not be able to get it. So I hope that the data becomes owned by who's rightful owner of it, shall we say, so the manufacturer's own. I also hope that we see a lot less of the proprietary nature of systems that have existed within the manufacturing plants over the years. They've made some progress, but they've got a long, long way to go. We really need to embrace open architecture, standardization within the manufacturing environment, so we can get to that plug and play sort of environment. It would make it a lot easier for everybody concerned. The integration costs would come down tremendously. The value that could be driven from the data collection and the use cases that can be served will be exponentially grown. So I hope that happens. So it just see in my vision of the future is you have this super data highway that exists within a plant. You can imagine all of these different data sources all going through this converged data pipeline that has multiple exits and multiple entries to it, and then it's serving everyone through the estate. So wherever you are within, with the correct security credentials, and it's protected in the right way, but wherever you are in that enterprise, you will be able to see the performance or the data associated with what you do from the machines, the equipment, the processes that matter to you, and you can get it on your desktop, and you can be able to get insight, and you can make fast decisions. That's what I really want to like to see. So the processes, all the technical difficulties are removed, and it's a simple, access it at all times, self-serve to data, and make good sense and good decisions from it.
I love that vision of it. And David Robertson, thanks so much for being with us today and sharing your expertise. I appreciate you joining us.
Thank you. Thank you.
And thank you for joining us as well. Another great episode of WWT Experts. Got plenty more coming up on the calendar going forward. A great back catalog you can watch on demand anytime. Head to wwt.com/events and check all that out. That's it for today. We'll see you next time.